Imagine a sudden crisis. Systems are down, decisions must be made, and every second counts. How well an organization responds is rarely left to chance. This is where testing comes into play, and at the heart of preparedness lies the tabletop exercise. A tabletop exercise is a scenario-driven discussion. Stakeholders gather around, virtually or in person, to walk through a simulated event. Each participant talks through their roles, responsibilities, and the choices they would make step by step. There's no real equipment, no rushing against the clock. Instead, it's about planning, probing, and problem-solving in a low-pressure environment. The benefits are clear. Weaknesses are revealed before crises strike. Communication channels are tested and improved. Team members build confidence and trust in their coordinated response. The result? A more resilient organization, ready not just to react, but to lead decisively when it matters most. Tabletop exercises aren't just a test. They're an essential tool for transforming plans on paper into real-world readiness. Imagine your critical systems suddenly fail. What happens next? Failover testing holds the answer. Failover is the process where systems automatically switch to a backup when a primary component goes down. This seamless transition keeps services online and users unaware of any disruption. But how do you know it will work when it matters most? That's where failover testing comes in. By intentionally triggering failures in a controlled environment, IT teams can confidently validate that backup systems respond as expected, data remains intact, and downtime stays minimal. Consider an e-commerce platform. If the main server crashes during peak sales, will transactions shift instantly to a standby server? Without regular failover testing, you risk costly outages and lost trust. To implement failover testing effectively, start by documenting all dependent systems, simulate a realistic failure scenario, and monitor not just the failover event, but the entire recovery process. Always analyze results and refine your procedures. Remember, reliable infrastructure isn't a matter of hope. It's a matter of thorough, ongoing testing. Every breakthrough begins with a question: does it really work? This single inquiry drives much of what happens in technology, engineering, and countless other fields. At the heart of finding answers are two powerful methods: testing and simulation. Testing is straightforward. It means examining a real system, product, or process under controlled conditions to see how it performs. For example, a car manufacturer crash tests vehicles to understand how they protect passengers. By observing actual results, professionals can confirm safety, reliability, or efficiency using real-world data. Simulation, on the other hand, creates a virtual model using mathematics and software to predict how a system would behave in the real world. Imagine engineers running thousands of flight scenarios on a computer before ever building a new airplane. This allows for exploration and discovery without the cost or risks of building and testing every idea physically. Both methods have their strengths. Testing provides direct feedback, but can be expensive and sometimes impractical for complex or dangerous situations. Simulation offers flexibility, speed, and safety, but relies on how closely the model matches reality. The most effective teams use a combination of both. They simulate first to narrow down possibilities, then test in real life to confirm and refine their results. This blend ensures innovation is not only possible, but also safe, reliable, and efficient. Whether you're building bridges, designing software, or working to improve everyday products, understanding testing and simulation opens the door to smarter solutions. These methods turn questions into answers, ideas into achievements. Imagine running a single test at a time. waiting for each to finish before starting the next. Now, picture launching dozens or even hundreds of tests simultaneously. This is the power of parallel processing in software testing. Parallel processing means executing multiple tests at the same moment, distributing tasks across different machines or processors. Instead of a linear queue, tests flow side by side, dramatically reducing total execution time. For example, when testing a web application, you can split test cases into groups. Each group runs on a separate server or virtual machine. What used to take an hour can now finish in just minutes, thanks to simultaneous execution. The benefits are clear: faster feedback, increased testing coverage, and more efficient use of resources. Parallel processing helps teams identify issues earlier, speed up release cycles, and deliver higher quality software, all without extra manual effort. Embracing parallel processing transforms testing from a bottleneck into a driver of innovation. Start small, scale up, and let your tests flow faster than ever before.